In this lab, management wants you to create some access control lists to restrict and allow certain access. Specifically, management wants a standard IP access control list, or ACL, to restrict the local area network 1, or LAN 1, from connecting to any other network. Management wants an extended ACL to prevent LAN 2 from being able to use ICMP pings to LAN 3. And management also wants an extended ACL to allow LAN 2 to access LAN 4. ACLs determine who can access certain areas of the network. For example, let's say you're standing guard at a club, and you're only allowed to let certain individuals into the club area. The access control list would tell you who you could let in and who you can't let in. So essentially, an access control list is a list that tells you who is and isn't allowed inside. Let's say we have a specific network segment that our virtual management interfaces are on. Well, we might only want to allow IT folk to be able to access them. We can do that by assigning IT individuals a specific IP network or a specific VLAN that is assigned a specific network, and then putting access control lists to filter out and prevent everyone except that network from accessing the virtual management interface. That's why IP access control lists are so important. So let's see what ACLs management wants us to make, and what company policy states for creating ACLs. ACL 1 is a standard numbered ACL. It needs to deny traffic from LAN 1, which uses the IP network 192.168.50.0/24, from reaching all other LANs and their networks. The security policy management has told us about also states that an explicit deny any access control entry, or ACE, should be present on all of our ACLs. What do they mean by an explicit deny any? Well, the deny any command is always the last line of an ACL, even if it doesn't show up as one of the command lines. It's invisible, it's implicit. But our company policy says we need to explicitly show that deny any command, so we have to type it in. So first, let's break down exactly what management wants with this ACL. So 192.168.50.0/24, which is LAN 1, should not be able to connect to 192.168.60.0/24, which is LAN 2, 192.168.30.0/24, which is LAN 3, and 192.168.40.0/24, which is LAN 4. So where should this specific ACL be placed? Before we decide, let's first see what type of ACL we're looking at. There are standard and extended ACL types. Standard ACLs only filter traffic based on the source or destination IPs. The IDs reserved for standard ACLs are anything between 1 through 99, or 1300 all the way until 1999. Extended ACLs offer more filtering options, such as the type of traffic, protocols, or ports allowed or denied for the IPs. The IDs reserved for extended ACLs are 100 through 199, or 2000 all the way up to 2699. Cisco recommends that standard ACLs be placed closest to the destination address to reduce the chance of legitimate traffic being blocked from the destination. If you accidentally put the standard ACL closer to the source instead of the destination, traffic that may be allowed in other areas of the network might get blocked by your ACL. But in this case, even though it is a standard ACL, we're specifically blocking only one network from the rest of the network. That means it makes more sense to put this ACL closer to the source, that one network we're blocking, and blocking it there. This means this ACL should be where LAN 1, which uses switch 1, connects to router 1. If this were an extended ACL, which included the destination we wanted to block and the protocols, for example, we'd also want it closer to the source. That's because if an extended ACL was closer to the destination, which is not recommended, then the specific traffic protocols, ports, and types that should be filtered out would be able to travel the network all the way up until our ACL, eating up bandwidth along the way before eventually being blocked. Before we implement the ACL, we need to make sure everything is working first before we start filtering and blocking traffic. Pause here to test connectivity from PC1 and LAN 1 by pinging PC2, PC3, and PC4 to see if PC1, LAN 1, is currently able to connect to the other LANs. Notice how they all currently work? This will give us a baseline, so when we make changes using the ACLs, we can see how our changes affected the network. Now let's start implementing our ACL. First, we need to create the ACL before we apply it. So let's go into router 1 and set up the ACL with the following command in global configuration mode. Access list 1 remark, deny access from LAN 1 network. Access list 1 deny 192.168.50.0, 0.0.0.255. Access list deny any. So what do these commands mean? Access list 1 lets us know that we are creating an access list identified as 1. Access lists can also use names instead of numbers. For example, we could have called this access list deny_LAN_1, but then we'd also have to specify whether the ACL was standard or extended, because it's not using the numbers that are in the ranges for standard or extended. It would be using a name instead. So we'll want to include 1 for any other entries that are related to this access list. Remark is a command that allows us to write something that explains what this access list does. In this case, the list is basically denying access from all of LAN 1's network from reaching any other network. The next line, access list 1 deny, means we're writing a statement to deny a specific IP address in this access list 1. Then we have the IP address and the wildcard mask, which is 255.255.255 minus the /24 subnet mask, meaning it's 255.255.255.255 minus 255.255.255.0, which is the /24 decimal notation, which equals 0.0.0.255, which is the wildcard mask. Finally, we have the deny any entry for access list 1, which we were told by management is required by the company's policy. Something to note is that the order of our entries matters. If we started with the deny all entry and then had some permit entries afterwards, all the traffic would be blocked, even though the permit entries were there. But that would be because the deny any entry was first, so everything was blocked before it could even get to the permit entries. Now that we built out the access list, which we called access list 1, we need to assign that access list to an interface. The source we're trying to block is the 192.168.50.0/24 network. That network is connected to router 1's interface G000, which has the default gateway for that network configured, which is 192.168.50.1, which is how we can tell that that interface is related to that network. So we'll want to apply our access list 1 to the G000 interface. But in what direction? You can put either in or out for the filtering. In would mean we look at the traffic as it comes into the interface and filter it with our access control list. Out would mean we look at the traffic before it leaves the interface and goes into the network, filtering it with our access control list. As we want to be closest to the source, we'd use the in command because in is the side facing the switch of LAN 1. So the actual command would be interface G000 to get into the configuration mode of the interface, and then IP access group 1 in. The IP access group 1 means to apply the group of filters applied to access list 1. And the in means that the traffic will be filtered just as entering the interface. Great. Now let's save the router configuration, update your notes, and save the Packet Tracer Lab. To see the list of ACLs on a router, let's do a show access list command in privileged access mode. Here we see sequence numbers next to each line, 10 and 20. The reason that there are sequence numbers is so we can add new permits or deny entries between, before, or after the different command lines if we had to later allow or deny more IPs that were coming in. We can add entries between the sequences by placing a number between, for example, 10 and 20 in front of our new entry command if we needed to. We can also remove lines by saying no and then the sequence number we want to remove. So right now we're going to remove the sequence 10 deny statement. Why? Because there's already a deny any statement, which means anything connected to the switch port will be denied. So if we remove the deny 192.168.50.0 network command, it'll still be denied anyways. So let's jump back into the ACL configuration in case you stepped out of it by typing IP access-list standard 1. Then we can type no 10 because that's the sequence number we want to get rid of. Now if we do a show access list, we can see that we only have sequence 20. We can also do a show access list 1 command to only see the rules of access list 1. To see where the access list was applied, we can do a show run and then just look for the access group 1 command on one of the interfaces. Or since we know which interface it's on, we could do a show IP interface G000 to see that it states inbound access list is 1. Alright, let's save your configuration and your packet tracer file and update your notes. Now, let's test the ACL. Try pinging the other PCs using PC1 again. Notice how now LAN 1 can't connect to the other LANs. That's because the link LAN 1 is connected to on the router is denying all the traffic. Okay, on to the next ACL. This time, management wants an extended ACL. The extended ACL needs to do two things. 1. Prevent LAN 2 from pinging LAN 3 with the ICMP protocol. 2. Allow LAN 2 to access LAN 4. Let's first get our baseline. Test LAN 2's connection to LAN 3 by pinging from PC2 to PC3. Then test LAN 2's connection to PC4 in LAN 4. Okay, now let's build out this extended ACL. First, we'll start with a remark statement. As this is an extended ACL, the access list number needs to be between 100 and 199, or between 2000 and 2699. So the command here we're using is access list 100 remark prevent LAN 2 ICMP to LAN 3 and allow LAN 3 to LAN 4. So we're using this remark to explain what this ACL is. Access list 100 deny ICMP is used for the protocol we're denying. 192.168.60.0 is used to specify the IP network of LAN 2 as the source. Then 0.0.0.255, the wildcard mask of the network. And now we can put the destination as this is an extended ACL. So let's put in the destination we're blocking LAN 2 from, which is 192.168.30.0 0.0.0.255, which is the network IP and wildcard mask of LAN 3. So this line altogether explains that we're denying ICMP LAN 2 traffic from getting to LAN 3. Now, to allow LAN 2 to access LAN 4, let's put in a permit statement. Access list 100 permit 192.168.60.0 0.0.0.255. And then the destination should be LAN 4's IP address 192.168.40.0 0.0.0.255. Finally, let's put in the explicit deny any command required by company policy. Access list deny IP any. Now we need to apply that ACL to a router port. So this needs to be closer to the source as an extended ACL. So let's put it on the interface that is connected to the LAN 2 switch, which is G002. We can tell that it's G002 as it's the one that has the default gateway of LAN 2's 192.168.60.0/24 network. Now, will it be in or out on the port? Think of which side is facing the LAN switch. So it would be in, as that's the side facing the LAN 2 switch. So the command on interface G002 is IP access-group 100 in. Okay, now save your configuration, save your packet tracer file, and update your notes. Let's see if we can verify what we changed by pinging from PC2 to PC3 and 4. Notice PC2's attempts to ping PC3 now no longer works as we're blocking ICMP traffic. But PC2 can still ping PC4. Great, so it worked. Now take the time to write your narrative. After that, share the Google Drive folder you have for this lab with the anyone with a link can organize, add, and edit access. Then, submit the lab for review. If you don't know how to submit the lab, refer to the instructions in the lab's intro video section of this program. After that, you can move on to the next lab.